In this video, we will be introduced to the components used in our course of study of electricity. Each slide will show a photograph of the component, its name, and the symbol used to represent the component in a schematic diagram. At the end of the video, there will be a short quiz so you can check what you have learned. This is a photo of 3 ceramic fixed capacitors which are able to store very small electrostatic charges. The capacitor can perform various functions in both electric and electronic circuits. This particular type is non-polarized, which means either of the 2 connecting wires can be the positive or negative lead. The symbol for the capacitor is representative of its physical construction, 2 parallel plates with a small space in between. The electrolytic capacitor also holds an electrostatic charge, but with a much larger capacity. Also, they have designated positive and negative leads, which must be connected correctly, or else the circuit will not function, and the capacitor might be destroyed. The leads are marked clearly on the capacitor itself, and the symbol shows the polarity graphically. The third type of capacitor we will look at is the variable capacitor. This has a set of semicircular plates attached to a shaft which can be rotated by turning the knob. This set of plates is called the rotor. A second set of plates, called the stator, is attached to the main frame of the component. When the rotor is turned so that the moving plates mesh with the stationary plates, the capacitance changes. The variable capacitor is primarily used for tuning radio and television circuits. Its symbol is similar to that of the fixed capacitor, except that one of the plates is shown as a curved arrow. In this composite photo, we see 2 coils being used for tuning radios. The upper photo shows the antenna coil with about 100 turns wrapped around a ferrite core in a tuning circuit of an AM radio. The lower photo shows an air coil with about 6 turns as the tuner of an FM radio. Coils are also used in electromagnets and relays. The graphic symbol is easily recognizable as an air coil. This next slide shows a transformer. This is a device for changing the voltage of an alternating current, either increasing or decreasing the applied AC voltage. It consists of 2 coils wrapped around a laminated iron core. The symbol is very suggestive of the actual construction. Diodes are semiconductor devices using either silicon or germanium to control the flow of electrons. They will conduct current when a voltage is applied in one direction, but not in the opposite direction. The symbol has a triangular arrow which points in the direction of current flow. And remember that current flow is in the opposite direction from actual electron flow. This photo shows several different types of fuses. The fuse is a safety device which protects circuits from being overloaded and possibly causing damage to the components of the circuit or even starting a fire. The fuse has a thin wire which acts as a weak link in the circuit. If more current flows than the rated amperage of the fuse, the thin wire will heat up and melt, stopping current from flowing. The symbol for a fuse is a short wavy line between the 2 terminal leads. In this slide, we see 3 relays of various vintage, but in each case the principle is the same. The relay is an electromechanical switch. A small input voltage activates the electromagnet and causes the spring-loaded contacts to close and complete a circuit. The symbol shows the electromagnet and the contact points and connecting leads. This familiar component is a 6-inch moving coil speaker. It has 2 input leads for the audio signal to be converted into sound. This size speaker is best suited to reproduce the mid-range of the audio spectrum. Larger bass speakers handle the lowest range audible to the human ear, and the smallest speakers, called tweeters, reproduce the high-frequency sounds. Sometimes the bass speakers are referred to as woofers, and the mid-range speakers are called squawkers. The symbol shown at right is very easy to recognize as indicating the audio output of the circuit. The layout of the audio circuit will usually place the speaker symbol towards the right side of the diagram. The invention of the transistor in 1947 was really important for the miniaturization of electronic devices that we see today. The transistor is a device which uses a tiny input voltage to control a much larger output. As such, it can act either as a switch or an amplifier. The three leads are called the base, the emitter, and the collector, and they must be connected correctly in the circuit, or they won't function correctly, and the transistor could be damaged or destroyed. The symbol shown indicates the names of the leads with the letters EBC, but the graphic inside the circle is sufficient to show which is which even without the letters. In order to handle the larger currents, the power transistor was developed. This is more robust than the regular transistors shown in the previous slide. Generally, a transistor is classified as a power transistor if it can handle a current of 1 ampere or more. The emitter and base pins project out of the bottom of the case, and the complete metal case is itself connected to the collector inside. The case can be screwed to a heat sink, which will help to dissipate any heat that might otherwise build up in the transistor. The symbol for the power transistor is the same as for a regular transistor. The last symbol in this video is for the chassis, or the ground. This is used both for safety reasons and to provide a common connection point in a circuit for several components. Examples of these connections are computer cases, automobile frames, and the ground pin in electrical outlets. The symbols are used interchangeably and are usually positioned near the bottom edge of the schematic diagram. Then other components higher up in the chassis don't require a line crossing the entire diagram to be connected to the chassis. They can be given their own chassis symbol to establish the connection. And this shortcut also applies to the actual physical circuit. For example, in a car, the rear lights only need to have their negative leads connected to the chassis of the car, saving a great deal of wiring. The next two slides have questions for review, so you can check what you have learned.